done. Okay, rational zeros. Here's the rule for it. Okay, this is what you need to know. If you start out with a polynomial, for example, let me do this one real quick. If I had given a polynomial to you in factored form, if I give you a polynomial in factored form, we talked about this a week or so ago. If you were to multiply this out, and you should have multiplied this out to the last test. This one problem was on the last test. Okay? What will your first term be?
It will be
X to the third, James says. He's correct. Because it'll start with an x times x times x. But you'll have some things in the middle, and what do you know your last term will be? Nope. 6. Because your last term will turn out to have been the product of 1 times 2 times 3. Okay, there'll be steps in the middle, but you don't so much need to worry about that. The important part, what I'm about to tell you, is that your last term is going to be 1 times 2 times 3. Any polynomial works that way as long as the leading coefficient is 1. If it begins with 1, in other words, if all you have is 1x times 1x times 1x, you'll end with a 6. Here's how that's useful in going backwards. I'm going to borrow one of these from the book, and we're going to start with an example of f of x equals x to the 4th plus 5x cubed.
This isn't going to be on the test, is it?
Oh yeah. Plus 5x squared minus 5x
What the heck?
minus 6. Now, listen carefully to these exceptions. Okay, the trick I'm about to show you only works if the leading coefficient is 1. Which one's the leading coefficient? The one on which term?
The first term. Add those together up top.
No, I multiplied them. That's a good point. That's a poor example because you can get it.
How do you get 5?
I didn't. I got 6. 1 times 2 times 3.
Oh, that's another.
This is a new example. Thank you, Cody. Yes, this is a new example. Did not do it. Okay. Otherwise, I wouldn't have started with x to the 4th either. Okay. The trick I'm about to show you only works if the leading coefficient is 1. The leading coefficient is on which term? X to the 4th. Even if they're out of order, it's always on the term with the highest exponent. Okay? So it's the one with the x to the 4th, and the leading coefficient is 1. So this trick will work. The other key... Oh, and the other thing you need to know is this only finds rational solutions. Nicely done. What does rational mean in this case? It's got to be real. That's one thing a rational number has to be. It has to be real. Only works for real solutions. Rational means also it can be made into a fraction. Okay, so that means it's not pi, it's not the square root of 2, it's not the square root of 17. This only finds rational solutions. If this polynomial has an answer like square root of 2, square root of 17, or pi, this trick will not find it. So you're out of luck on that one. But this is a good start. Okay. Under this situation, leading coefficient is 1 and looking for rational solutions. Here's the rule. Possible rational solutions are positive and negative multiples of the constant term. God, that sounds more complicated than it is. What's the constant term in this polynomial? -6. -6 is the constant term. It's the term which is a number. Possible rational solutions are all the positive and negative multiples of the constant term.
So what's the constant term?
Constant term is, let's do this in another color here. Every single one is a possibility, not a guaranteed solution. So 6 is the constant term. -6 is the constant term.
But like, what's the definition of it? It's a single number?
Yeah, it's the number at the end without an x on it. It's a number it's the term that only has a constant, does not have a variable.
So it's gotta be like 61.
Well, so here are the possibilities. That means plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6 are our possibilities.
You said multiple, not factors.
Good point, so I've been hammering what the word factor means. I should have used factors up there. I'm going to let that stand for now. Yeah, we'll talk about that difference later. Good point. Good point. Do you prefer to use factors here?
I mean, I don't care, I just figure out what that.
No, that's a better word. Factors, the way I've been using the word factors, that's a better way to go, actually. Either way, it's all the things that can possibly multiply evenly into net positive or negative
Okay,
6.
see, that makes it a lot easier. I thought you meant like things that you can,
Oh, like 12, 36,
Yeah.
18, 24?
that's why I said all.
Yeah, no, good call. Thank you. Excellent. Factors is the right word. Excellent point.
And that's the reason I had asked earlier if all of them were a possibility.
Because that would be an infinite number.
Yeah.
Excellent. No, good point. It's not. It's just the things that can multiply into your constant term. Okay, so these, thank you, Cody. These are your possibilities. Now, the reason why I wanted you guys to practice synthetic substitution and synthetic division so much is because that's the fastest way to check if your possibility is real. Because here's the part that is either long and involved or tests your luck.